we put the law of sines at the very end of the previous video. We kind of hinted at a proof. There's no way we're going to have time to prove the law of cosines right now. It's a little fancier, the law of cosines is. But I can certainly write it down.
Okay.
And I can certainly tell you kind of how to use it. All right?
Okay.
So here's how you think about the law of cosines. Imagine that this angle were a right angle.
Okay.
Okay? Then the Pythagorean theorem would apply to this triangle.
Okay.
And it would say a squared plus b squared, and I'm going to leave some space, equals c squared.
Okay.
Right?
Mm-hmm.
But this is not a Pythagorean triple. I mean, this is not a right triangle.
Okay.
Right? In fact, c is too short to be a hypotenuse. This is too short.
Okay.
Right? So to fix that, we need to subtract something
Okay.
from the left-hand side. And it turns out the thing that we need to subtract is 2ab cosine of the angle C.
Uh-huh.
And there you go. That's the law of cosines. The way it works is this. If I have this side and this side and the angle between them, I can get the other side.
Okay.
So this whole left-hand side of the equation is exactly side A and side B and the angle between them.
Okay.
They join forces in this weird equation to produce the side opposite.
Okay.
Okay? Now I mentioned that we're going to do maybe some regular geometry. And I'm going to indicate what you would learn in a regular geometry class, and that would be two triangles are congruent if they satisfy, we'll call it side angle side, which is what you'd call it in geometry class. Have you seen this before?
A little bit.
Have you seen side angle side?
I think so.
So let me give you an example of side angle side. Let's say that I'm just going to make up a totally random example.
Okay.
Okay? And so let's say I have two triangles like so. And I'm going to call this line segment right here, I'll call it AB. And I'll call this line segment right here, I'll call it CD. Okay? And I would say an example problem might be if I was given that M is the midpoint of CD and it's the midpoint of AB. What I might have to prove is that triangle AMC is congruent to triangle, and that doesn't look like a TP, not a triangle, BMD. Okay, and I'm just going to sort of sketch the proof without even really writing it out. But the point is that this side, AM, this line right here, AM, is the same as MB.
Okay.
Because M is the midpoint of AB. Got that?
Yes.
The side CM is the same as the side MD, because M is the midpoint. And then this angle is the same as that angle, because they're what's known as vertical angles.
Vertical angles. Okay.
Have you seen that before?
Yes.
Vertical okay. So then I would conclude by side angle side
Okay.
that the two triangles are congruent, because I've shown that they have this side equal, they have this side equal, and then they have these angles equal.
Okay.
Okay? Okay, so there's an example of how you might use side angle side in like geometry for middle school kids or elementary school kids. And then you grow up and you take like algebra 2 or pre-calculus, and suddenly, instead of side angle side, what you have is the law of cosines. Okay? And all the law of cosines says is that if you know this side, and you know this side, and you know this angle, you know all three sides.
You know everything.
Right. And that's exactly what the side angle side theorem says in geometry.
Okay.
Two triangles that satisfy side angle side are the same.
Okay.
The other thing is about the law of cosines is if you know all three sides, you can use this equation to solve for the angle by using inverse cosine.
Okay.
Okay, and I'll do an example of that. So, what if I told you that, oh no, I'm using pink, evidently. Let's say this side was 6, this side was 7, and this side was 9.
Mm-hmm.
Okay?
I don't see anything special about those numbers.
Neither do I just made them up. So I wanted to figure out what theta was. Okay? Then I'd say 6 squared plus 9 squared minus 2 times 6 times 9 cosine theta equals 7 squared. I hope the numbers work out. 36 plus 81 minus 108 cosine theta
Is equal to 50.
equals
Oh, 49.
49. Okay?
Well, then you would add these two.
Right. So, okay, I'll do it really quickly.
Okay.
All right? So, I'm going to do this. 36 plus 81 minus 49 equals 108 cosine theta.
Mm-hmm.
Okay? And what's the easiest way to add this? 81 minus 49 is 52. So this thing right here is 52.
Yeah.
No, not 52. What am I talking about? You should say, what are you talking about, crazy person? It's 32.
32.
This is 32.
Mm-hmm.
And then 32 plus 36 is 68.
68.
So 68 is 108 cosine theta. So in the end, cosine theta is 68 over 108.
Okay.
And the calculator will tell us what theta is.
The numbers kind of work out. 17 over 27.
Now do the inverse cosine of that.
And the numbers are 50.9771977
Okay.
dot dot dot.
So 50.97 whatever degrees. Now, ultimately, between the law of sines and the law of cosines, what we end up with are formulas that apply to all triangles, not just right triangles.
Okay.
And this is sort of, we're now getting to a point where we have trig equations and trig knowledge that is helping us solve problems that we couldn't solve before, right?
Okay.
Because now we have formulas, law of sines and the law of cosines, that work for any triangle,
Okay.
not just right triangles. Okay, so that's like that should be motivating. It should be like, all right, trig means something. Trig's a good thing. Okay.